Hello students, welcome to the classroom chemistry. Here you will enjoy an experience of classroom teaching. It's my second video for the chemical bonding. In my previous video I have explained you the electronic theory of chemical bonding. This electron theory of chemical bonding was told us by Covalent and Lewis. They also told us about the octet rule, and according to this electronic theory of chemical bonding, the bonds are of two types. One is the electrovalent bond, first one, and second one is the covalent bond. Electrovalent bonds takes place through the exchange of electrons, and the covalent bond takes place through the sharing of electrons among atoms. So today I am going to explain you this covalent bond. So for the covalent bond, take an example. Suppose these are two atoms. This is A atom and this is B, and this A atom has one electron and this B also has one electron. All the electrons are equal, similar, but I have shown you here the cross of this electron and this dot electron for the B. So again, when they come closer, these electrons, the electron of each atom will share to each other, will come to close each other, A and B. This is the sharing. This electron pair is called as the bonded electron pair, and the counting of this electron pair will be done in the favor of A and as well as in the favor of B. In other words, you can say this bonded pair of electrons will be counted on both the sides towards A and towards B. So again, say second one pair of electron forms one covalent bond, and two pair of electrons form two covalent bond, and three pair of electrons or the bonded pair of electrons form triple bond. So I will explain you one by one. So here this A and B, you will show the bond, the covalent bond by a dash. This one is the sign of covalent bond. Covalent bond. This is called a single bond. Now for this, take the example of chlorine. As you know, the chlorine atom has 7 electrons in the outermost orbit. So each chlorine, you will write here in this way. You can write directly. You can write here. This is show chlorine. These are the 7 electrons in this chlorine. These are the 7 electrons of a chlorine atom. So how many electrons this chlorine atom requires to complete the octet? Only one electron. So it requires one electron to complete the octet. So that electron will be by sharing this electron of the second chlorine, and this chlorine also have 7 electrons. This chlorine also has. I have shown you in different types. The dotted electrons of this chlorine and the cross electron of this chlorine. One electron of each chlorine takes part in the sharing, and this is called as the bonded pair of electrons. And this bonded pair of electrons will be counted on both sides for this chlorine. Now it is counted in this chlorine, and when you draw a circle in this way, this electron. So this circle shows us that the counting of the bonded electron pair will be done on both sides, on both sides of the atoms. So again you can write here Cl dot Cl. It is the molecular formula of Cl2. Again, this is all about here. Now I will going to when the double covalent bond are formed. So again, take the example of O2. This is O. This is O. How many electrons are there in the outermost orbit of oxygen? There are 6 electrons. So you can write here 6 electrons. These are the 6 electrons. Again, the second oxygen will also have the 6 electrons. So each oxygen requires 2 electrons to complete its octet. So all the 2 electrons of the each oxygen atom will take part in the sharing. Again, this you complete this 6 electrons with like this, in this way. These are the completion. Now this is the octet of the first, this one oxygen, and this is the octet of the second oxygen. So the double bond between oxygen and oxygen is formed. It is the Lewis structure of oxygen atom, oxygen molecule. Now I am telling you about the third. I am taking the example of nitrogen. Nitrogen has 5 electrons in the outermost orbit. So there are 5 electrons of the nitrogen. How many electrons will it take to complete its octet? So there are 5. So naturally it needs 3 electrons to complete the octet, and then the sharing of the 3 electrons will take place between two nitrogen atoms. These electrons come from this nitrogen, and again you will show. It is clearly showing that these 6 atoms and 6 electrons and 2 electrons, it completes the octet, and for this nitrogen, it also. So both the nitrogen completed the stable octet, so they form the molecule of nitrogen. How many bond will form between the 2 nitrogen? There are 3 pair of electrons, bonded pair of electrons, so it will be called N and N. So in the nitrogen, you will find triple bond. Now I will tell you more examples about the picture. So take the example here of HCl and hydrogen. You can take as many as the practice you will do that will be beneficial for you. So do more practice as you can. So for a hydrogen, this is hydrogen, and 1 electron from each hydrogen. This is the structure of H2. Now take the example of HCl. This is hydrogen, this is 1 electron, this electron is from chlorine. So you can write in this, it's very simple. So it is for, and this. I think that you are good. This is HCl. This is about the HCl. Now I am taking the example of NH3. Suppose there are 5 electrons in the nitrogen. See, it is the 5 electrons in the nitrogen. So 1 electron from 1 hydrogen, this electron from second hydrogen, and this electron from third hydrogen. So the octet is complete in this way, and here nitrogen, all the hydrogen have 2 electrons. So here, this one is the structure of ammonia, NH3. This is the structure of ammonia, NH3. Here, 2 types of the paired electron. One this pair, this one pair and this pair. This pair is called the bonded electron pair, and this pair is called lone pair. Lone pair, the pair which doesn't take part in the bonding, that is called the lone pair. The pair that doesn't take part in the bonding, that pair called the lone pair, and the pair that takes part in the bonding, that called as the bonded pair. Bonded pair, bonded pair of electrons. Lone pair, that is lone pair of electrons. So this is the structure of NH3. Now I am telling you about this is carbon. This is carbon. Carbon has 4 electrons in the outermost orbit. So one electron is from hydrogen, one electron is for hydrogen, one electron is from hydrogen, and this is the structure of methane. This is the structure of methane. So you can write here CH4. Again, CH4 again, and carbon. This carbon has 4 electrons, this carbon has 4 electrons and 2 electrons. Each carbon shares 2 electrons. Each carbon shares 2 electrons with the nearest carbon. Then here in this case, so and this here hydrogen. It is for hydrogen. This is hydrogen. This is hydrogen. This is hydrogen. This is. So this duplet of the hydrogen is formed here, duplet, and the octet of hydrogen, octet of the carbon. This is the octet of this carbon. These 4 electrons will be counted to this carbon, and this 4 electrons will be counted to the another carbon. So it will 4. So now the structure of C double bond C and H. This is the structure of ethylene. Structure of you can say ethylene, or you can say ethene. Simply in IUPAC it will be called as ethene, or in old stream it is called as ethylene. Now for the acetylene, you know the acetylene, when the 3 electrons of each carbon takes part in the sharing, each carbon. So here, this one, this is of hydrogen, this is of hydrogen, 6 and 2, 6 and 2, this is 6 and 2, this 6 and this 2. So this is all about the acetylene. This is the structure of acetylene. Acetylene, or you can say in IUPAC it is ethine and acetylene. These are some structure I have told you that shows up this is the single bond. Here I have explained you in the single bond. In the ethane, then you can say here when takes its part 1 and 1 like this, and 1 hydrogen. This is hydrogen. So all the carbon has its octet, or this carbon has its octet, and all the oxygen, hydrogen has duplet. So here in this way, this is the structure of ethane. This is the structure. Here is single bond. So I have explained you the single bond, double bond, and the triple bond. Now I am coming to a second formation. Suppose take the example I am telling you about the carbon dioxide. I am telling about the structure of carbon dioxide. The carbon dioxide CO2, 1 atom of carbon and 2 atoms of oxygen. So we'll write here this carbon, this is the carbon, this is carbon, and 2 electrons of this oxygen and 2 electrons of this oxygen will take part in sharing, and rest of the 4 electrons you will show like this. You will show like this. So these are the 6 electrons which are represented by the dot of oxygen. These are the 6 and 4 electrons of the carbon. Now this one is the octet of this oxygen. This one is the octet of this oxygen, and the octet for this central carbon. So in this way, the CO2 is formed like C double bond O and C double bond O. Now I am going to explain you some structure that is special. Sulfur dioxide. Take the example of sulfur dioxide. So sulfur dioxide, sulfur has 6 atoms. Sulfur has 6 atoms in the outermost orbit, and this O has its 6 atom in the outermost orbit. This is the oxygen. So again, this oxygen has completed its octet, and sulfur also has completed its octet. Now the second oxygen, how will you link with this sulfur? The second oxygen, this oxygen has 6 oxygen. In this case, think about this case. So here, such type of this sulfur will give this electron to this oxygen, and the sharing of that electron will take part. Or indirectly you can say this lone pair of sulfur will be a shared pair of electron, both sulfur and the carbon. So it is counted. So again, this is sulfur. These 2 electrons are counted for this oxygen. Now you can say that this sulfur, this is O, and this electron was given to this oxygen, and again this oxygen shared with this. So you can write in this way. Somewhere in the books you will find such type of bonding. Such type of bonding are called as coordinate bond. Coordinate bonds. These are the coordinate bond. But now we don't write this coordinate bond like this. We will say that as double bond O. 1 electron was given to this oxygen, and then they shared with each other. So this oxygen has positive charge and this oxygen has negative charge. To show this oxygen, this is the structure of sulfur dioxide. Now I am telling you that this is ammonia. I have explained this is one, this is one, and this ammonia has 1 lone pair. The lone pair means the pair that has not taken part in the bonding. Then this H positive, when it comes to it, this electron will go to this, and so first you can say that the bond is formed like this. This bond is, but it's not the way. You will say that this is H and H and H. This H. This H is, so again this is the positive. So this nitrogen has positive. Again you will write here on this positive. This is the structure of NH positive. So these such type of bonds are formed with the help of the coordinate bond that once it was given. So again such type of the bonding. So this was all about the covalent bond. I have told you the single bond, how to form the single bond, double bond and triple bond by the example of this. So all about I have this, and that's all for today. So please like this and share this video to your friends and subscribe to so that my coming video the notification of my coming video will reach to you. So that's all for today. Thank you very much.